Okay, yeah. So we are live now. So hey everyone, welcome to the community where masterclass organized by Foundership. Hope you all are doing very well. And good evening. To those who do not know about Foundership is an emerging tech accelerator providing incubation to Web3 plus generative AI startups through its flagship acceleration program called 0x Camp. We have another cohort coming up this month, and the applications are now open. Do check out our blog via the link shared through the chat. To know more, kindly visit our website at foundershiphq.com. Embarking the journey from idea to implementation in the realm of blockchain technology requires a comprehensive strategy, particularly when launching a rollup and Appchain. This intricate process involves weaving together concepts of layer 2 scaling solutions and sidechains, promising enhanced scalability and functionality for decentralized applications. Today, we are joined by Dr. Ravi, CEO and co founder at Zeev, a blockchain development and management platform. This masterclass will aim to traverse the stages of conceiving, planning, and executing the launch of a roll-up and app chain, shedding light on the critical considerations, challenges, and innovative solutions that pave the way from concept to a fully functional blockchain ecosystem. The live chat has been enabled for questions. Do feel free to clarify your doubts, which will be taken towards the end of the session. Over to you, Ravi.
Yeah, thanks, Vardit. Hi, everyone. My name is Ravi. I'm the co-founder CEO of Z. And so today we'll talk about, the new area in the Web3 space, which is the application-specific blockchains. So let me just, put this into full screen. So I hope you can see my screen now.
Yes, it's visible, Ravi.
So the first and foremost is, what is the concept behind application-specific blockchains? Why they are needed? So as we know, blockchain started with Bitcoin, and then Ethereum came in. Ethereum launched with smart contracts, and smart contracts allowed a lot of applications to be built on blockchain. It was not just a payment app or a token, but you can build even more complex applications involving smart contracts. It may be decentralized exchanges or lending protocols or supply chain track and trace in the enterprise space. So we saw a lot of surge in the adoption and transactions happening on the blockchain. And as we know, these layer 1 blockchains were monolithic, and scaling of these blockchains was very difficult. And there is a reason for that. So that is the way how a distributed network or a decentralized network is architected. And there's a classic blockchain trilemma, and the whole limitations that we see as per the trilemma is because of the blockchain architecture. So in blockchain, what we need is, we want the network to be highly decentralized, and decentralization will bring in more security. So security and decentralization, if you see, we require, if you take an example of Ethereum, we require more and more nodes on the network. As the number of nodes on the network increases, more and more people are setting up, being a validator on the chain, and these people are unknown to each other. So that means you can actually trust that network. So the security and the decentralization of the network is going to increase as we have more and more users. But as you know, in the blockchain networks, the propagation of transaction, when you do a transaction using your wallet, you're actually doing a transaction that goes to the nearest node that you have. Now that transaction needs to propagate across all different nodes on the network. But there is a block finalization time, and there is a time that it takes for a transaction to be propagated using gossip protocol to different nodes. So as you increase the number of nodes, of course, it becomes difficult for you to propagate in the limited time that you have, right? So that means if we try to increase the speed at which the blocks are written, or we try to increase the size of the block to get to contain more transactions, in both these cases, we'll find that there comes a limitation when you talk about decentralization and security. So that's why scalability, on one hand, where we want to have more transaction throughput, we want to do more transactions per second, but that is limited by if you want to increase security and decentralization. So that is the classic challenge. And we have seen that, as Ethereum grew rapidly over the period of 3 to 4 years, we started seeing that as soon as a new application comes in um, and requires or gains huge traction in the short term. For example, I remember in 2017, CryptoKitties came in. So CryptoKitties was an NFT kind of game. You buy kitties, and then you groom them and so on and so forth, and you sell and buy and so on. So there was a lot of traction. It was something new in the blockchain space, and suddenly the congestion on Ethereum became so high that the gas price shot up. The gas price became very exorbitant. If you want to do $100 worth of transaction, it was not even possible to do that. The cost of gas maybe even 20-30% or even more than the cost of the value of transaction itself. So it has been an endeavor that how to solve the scalability challenges. And there were different approaches. I won't talk about those approaches, like bringing sharding into the chain, or let's say increase the block size, and various other initiatives at a Lightning Network, as we saw in the case of Bitcoin, to increase the throughput at the layer one level itself. But they have got a limited option for scalability. The second drive which came was the whole concept of application-specific blockchains. So this is one dimension, the whole scalability piece. The another dimension for application-specific blockchains is, just imagine you are running a Web3 startup, a decentralized application on Ethereum or Polygon. Now, what happens when you deploy your smart contracts on the main Polygon chain or the Ethereum chain? You're actually sharing resources with other applications that are running on that network, right? So, and then your application also uses gas fee. Your users, when are doing transactions on your dApp, they are paying the gas fee for every transaction. Now, your gas fee is outside your control as a startup. The gas fee is completely determined by the activity on the network itself, right? So that means the gas fee is not in your control. It's not predictable for you or for your users. And third is, let's say you want to build in some compliances. You are building something in healthcare, or you are building a decentralized app and you want to bring in some privacy into it or some kind of compliances into it, like what we are seeing in real world asset tokenization. A lot of new token standards are coming in. But just imagine that those standards are not available right now on the main chain. Now, in all these scenarios, what you require is more of your own dedicated blockchain, right? So it's very similar to what we saw in the Web 2. There's a shared hosting, there's a dedicated hosting, where you're not sharing resources. You have a root access, you can make changes, you can do your own set of configurations. So these are two dimensions due to which this concept of application-specific blockchains came in. Now, if you see what are the benefits? Of course, one is the scalability, that now you are not competing for the same block space with other dApps on the network. By launching your own application-specific blockchain, you have full control over the resources that you have. You can design your deployment architecture, your cloud architecture, whichever way you want, right? And second, you have a predictable gas fee now because you control the gas fee. You have your own native token, and you control that piece. The second is customization. So as I mentioned, you can have now your own set of configurations, maybe related to privacy. It may be related to throughput itself. You want to have a different kind of throughput into it. So you can customize your own application-specific blockchain whichever way you want. Now, the third piece is security. Now, that is something very important to understand, that why we are talking about Appchains today only. Just imagine that, let's say you want to launch your own blockchain, your application-specific blockchain. You could have done that 5 years back also. And at that time, a lot of new blockchains came in, and the primary way of doing was to fork an existing blockchain. So there were there were a lot of blockchains that got launched in 2015-16 by creating a fork of Bitcoin. And then, in 17-18 and beyond, a lot of forks were created out of Ethereum, and then various other blockchain protocols. But the challenge with that kind of approach is that you are creating your own blockchain, a layer one blockchain. And when you launch a layer one blockchain, that it comes with its own set of yes, you definitely get a lot of benefits in terms of your own customization, your own gas fee, etc. But then how to secure that new blockchain? You need to have good number of validators to validate on that chain. You need to bring a large community to get these validators and people who are excited about your layer one blockchain. But end of the day, what you wanted to launch was just an application, and your focus was to build and launch an application. Your focus was to bring more users, gain more transactions, and focus on the growth of the startup itself, right? But now you have to worry about some of the pieces like bringing in more validators, more security, more decentralization. That becomes a big overhead. So that's why that is not something which was desired for most of the players. Until unless you want to launch a general purpose blockchain, your own layer one, and want to compete with the other layer ones in the market, then it's a different story. But I'm talking about, let's say you're launching your a decentralized application. Now, what happens in the case of Appchains? In the case of Appchains, the security is leased from the main chain. So if you're launching an application specific blockchain on Ethereum, on top of Ethereum, then you are leasing security and decentralization from Ethereum. And what you're giving back to Ethereum is scalability. And we'll come to that. But to understand that, the application specific blockchains are pretty secure because they lend or lease security from the main chains. So now, as I talked about, what are the different ways of creating your own application specific blockchain? So one, there are some very mature standard frameworks. One is Cosmos SDK, another is Substrate, where you can use these frameworks to create your blockchain. And I'll shortly talk about it can be an independent chain, it can be connected to the main chain, depending on how you want to launch your chain. The second is there are a few side chains or subnets or supernets kind of concept that have come in, where you create a side chain kind of blockchain, which is an app chain, and then you connect it with the main chain. Again, you lease security from the main chain, and at the same time you are running your own set of transactions, your own token economics, control over the gas fee, etc. And a part of that is the third category, which is rollups, optimistic rollups and ZK rollups. Here again, you are creating a separate chain, and you are connected with the main chain for security and decentralization. So we'll talk about these three in the coming slides. So first, we'll quickly go over using frameworks. Let's say you want to launch a Cosmos-based chain or a Substrate-based chains. So these are two most popular, very mature, have been in the market for quite some time. So here the central idea is that when Cosmos launched and Polkadot launched their network, they said that, what we are launching is not just a single layer one chain, but it's a network of networks. So that means like a hub and spoke model. There's a Cosmos hub, and similarly Polkadot main chain acts as a hub. And then you can create, using Cosmos SDK or Substrate framework, you can create your own application specific blockchain, and then you can run it independently if you want. But then again, those challenges will come in, bringing your own validators, etc. Or you can connect it with the main chain, like in the case of Cosmos hub, in the case of Polkadot main chain. So that's how so it gives you an option to create an independent chain also, and at the same time an application specific blockchain connected to the main chain. So in the case of Cosmos, the best part is Cosmos SDK allows you to launch your Tendermint consensus based blockchains. They provide all modules so that you have block explorer, you have different set of modules, you have a choice of consensus like using proof of stake or proof of authority. And then there are a lot of built-in modules that you can pick and choose, and then there is a documentation where you can create your own modules. So it's pretty much like a framework where you can use Cosmos SDK and you can create your own custom blockchain. Some of the examples of Cosmos-based chains are DYDX, which is a decentralized exchange, or Osmosis, which is a cross-chain liquidity backbone for Cosmos ecosystem. And then Corium is a layer 1 blockchain. It's a Cosmos SDK based chain, but it itself is a layer 1 blockchain. It's an independent from Cosmos. And it has been designed focusing on real world asset tokenization. So that is what the major focus of Corium is. And one interesting thing in Cosmos is that all the Cosmos chains, so if you build your app chain using Cosmos SDK, you are by default, there's a IBC bridge. So you automatically become, you get interoperability among all the different Cosmos SDK based chains as well as Cosmos main chain using the IBC bridge. Now, the second, we talked about Substrate. So Substrate is, again, a framework to create your own blockchain. This is being managed by Parity Web3 Foundation and part of the Polkadot. So Polkadot has been built using Substrate. Substrate has created its own ecosystem as compared to the EVM ecosystem of Ethereum. And there are some obvious differences. So Substrate, the smart contracts are not in Solidity but Rust, which is a low-level language and makes the execution of smart contracts much faster. The Substrate has created its own very popular ecosystem. A lot of developers, a lot of apps are being built on Substrate. Now, again, like Cosmos, using Substrate, you can create an independent chain. So it will be called like a Substrate chain. There are quite a few Substrate chains today, like Vara Network. And at the same time, you can create a parachain. So if you plan to connect your Substrate blockchain with Polkadot main chain, then it's called parachain, a Polkadot parachain. And there are two options. There's a Polkadot ecosystem and Kusama ecosystem as part of the Polkadot. And you can create your parachain on either of them. So there's a process of, you need to go through an auction process to lease parachain space with Polkadot or Kusama both. And then, but you can connect it. And by connecting, again, the same concept, you get the security and decentralization from the main chain. But if you choose to launch your independent Substrate chain, then it's like a layer 1 blockchain. You need to bring in your own validators and so on and so forth. So until unless you plan to launch a general purpose blockchain, it makes more sense to launch a parachain. And again, there are interoperability. There's a messaging protocol which Polkadot launched, which allow interoperability to happen among the different Substrate chains and Substrate and Polkadot. Some of the Polkadot parachains or Substrate-based chains are Akala, which is a DeFi hub. Moonbeam is one of the biggest parachain in Polkadot ecosystem. The beauty of Moonbeam is that it supports both these smart contracts. It supports the EVM compatibility. So that means that you can deploy your Solidity contracts on Moonbeam. And at the same time, you can use all the tool infrastructure that is available for EVM chains like MetaMask or Remix, etc. And at the same time, Moonbeam has the underlying Substrate chain running. So it also allows you to have your Rust contracts. So it gives you a choice of both. And then Turnova is an evolutionary NFT-based blockchain. And they have created a very solid infrastructure with trusted execution environment to create secure NFTs and have a very secure and private infrastructure to manage that. The second option now we'll talk about is subnets and supernets. So subnet is something which was launched by Avalanche, and Supernet was launched by Polygon. Earlier, it was called Polygon Edge, which was renamed into Supernets. So these are, again, if you want to launch your application-specific blockchain, these are two options. You can use a subnet and Supernet. The benefit of subnet and Supernet is, unlike Substrate and Cosmos, they are even lesser complex, because a ready framework is already, a ready-made blockchain is already there. Still, it's your own blockchain. You can do customization if required. So there's an option to do a customization. But apart from that, you can easily deploy them. They are very mature. They are very light, and you can launch very quickly if you want to go the subnet or the supernet route. So here the concept is, let's say we take an example of subnet. So Avalanche is running a main chain, right? And when you launch a subnet, that means your own set of nodes. And you can have your own native token. You have your own native token economics, etc. And at the same time, the validators who are validating on the main chain need to validate on your subnet. So it's the main chain validators, they need to validate on your subnet. So that way, your subnet on the day of its launch is pretty much secure, because minimum 5 validators on the main chain who are validating on the main chain needs to validate on your subnet. And plus your subnet is connected with the main chain. So that way you are able to get the security and decentralization from the main chain. And yet at the same time, it's your own independent blockchain or application specific blockchain. You can put in any kind of application, put in any kind of configurations, resources, etc. Second good thing about Avalanche subnet is that the throughput is very high. Like if you see Avalanche mainnet, that itself has got a throughput of more than 4,500 transactions per second. And with your subnet, you have a full control over what kind of TPS you want. Some of the subnet-based Appchains are Remedy and Meld. Both are Zeev customers. Remedy is a healthcare platform based out of US, and they use subnet because they wanted to have privacy, especially handling personally identifiable information of patients and a lot of healthcare data. And they chose subnet to have their own blockchain. So bring in the value of blockchain, the trustlessness, decentralization, etc. But at the same time, apply all the compliances, data compliances related to healthcare within the platform. And then they are able to get the security and decentralization from the main chain. Meld is a DeFi protocol and a neobank, and they provide cross-chain lending, borrowing, and staking on the Meld blockchain. They are already supporting some of the leading blockchains in the EVM ecosystem, and they have also launched their own subnets. And then there are quite a few today. There are about 70 plus initiatives happening on launching their own Avalanche subnets. The second option within this category is the Polygon Supernet. So Polygon Supernet started as Polygon Edge, and again, like subnet, you can easily launch your Polygon Supernet, and you get connected with the POS mainnet. The Polygon POS mainnet, provides you security, etc. In this case, there's no limitation of main chain validators validating on your supernet. That is not required. But rest, conceptually, it's pretty much same, like behave same as Avalanche subnets. So right now, Polygon's focus is not much on supernets, but supernet is definitely an exciting and excellent proposition. Some of these supernet-based app chains are like Gnosis Pay, and then Outer Life. They are using Polygon Supernet. Some of these customers will definitely evolve into and migrate to ZK Rollups. So just to recap the first two categories, we talked about launching using standard frameworks like Cosmos SDK or Substrate framework, and then the second option was to if you want to have a quick launch with mature app chains like Avalanche subnets or Polygon Supernets. Now, this third category is something which is has gained maximum traction, because here you are weeding away a lot of challenges in managing a complex infrastructure. Obviously the technology stack is very complex at this point of time, but yeah, as more innovations keep on happening in the ZK Rollup space, we are going to see it becoming more and more easier. So the concept of rollups is, I think, very. So the initial concept that we discussed about, how an app chain works. I think rollup is something very interesting to understand it. So if you see like what happens in the case of Ethereum. So there are two kind of information on Ethereum blockchain. One is transactions, and the second is data, right? Now, if you want to store all the transaction information on the blockchain, right, like on chain, then it is pretty sizable and it takes a lot of block space. But if you talk about the data which results from a transaction, that is, that pretty much remains the same. It's pretty much like a check. You can put in any kind of amount. The weight of the check will remain same, right? So the whole concept of rollups was that why not do the transactions outside the blockchain into a rollup, and then you roll up these transactions, you combine all these transactions and package that into one transaction on the main chain. So that way, now what you are doing is you are directly aiding in increasing the scalability on the Ethereum main chain, because most of the transactions are now happening outside Ethereum. Still, the rollup is itself like a blockchain only, but it is not structured like a blockchain. What we saw with Cosmos SDK or Avalon subnets, uh, they are pretty much like your own blockchain, which has got a standard blockchain architecture. There are RPC nodes, there are validator nodes, etc. The the technology stack for rollups is quite different, but yeah, the process pretty much remains same. So you launch your own rollup. Uh, just a second. So you basically launch your own rollup. You have your application deployed on your rollup. Your users do the transactions. The transactions are happening on your rollup, and then you take a certain number of transactions, and then you submit those transactions as a single transaction onto the main chain. And so that way, now more transactions can be done with a predictable gas fee, higher transaction throughput, lesser gas fee, and you're not adding to the congestion on the Ethereum main chain. So that's essentially what rollups are. And there are two kinds of rollups today. One is the optimistic rollup, and the second is ZK rollup. Both are on a high level. End of the day, they are rollups, so their high level process remains same. As I mentioned, you take the transactions, you compile them into a rollup, and then you roll that up onto the main chain. But the technology stack underlying both these rollups is quite different. So optimistic rollups, as the name suggests, optimistic. They are based on the assumption that they are going to do a quick validation on the rollup and then submit the transactions on the main chain. And there is no additional validation that happens. And that's the reason in the case of optimistic rollups, there is a time given, where somebody can submit a fraud proof. So I'll explain by this process. So in the case of optimistic rollup, what happens is, one, there's an off-chain validation that happens on the rollup itself. And then, there's a block aggregation. So all the transactions are packaged into a block. And then, the block is submitted as a single transaction on the main chain. And then once it has been submitted, the underlying data, so not all the data is submitted on the main chain. It's just the hashes that are being submitted on the main chain. And the data still resides in an off-chain DB, it may be IPFS or some kind of decentralized storage. And anyone can, use that data to create a hash and compare it with the hash that has been submitted on the main chain. So these are called fraud proofs. You can submit a fraud proof if you find that there are some incorrect transactions. And one who submits the fraud proof and it is shown that, yeah, there has been incorrect transactions submitted on the main chain, then the person who is submitting the fraud proof is rewarded, or else he's punished. And if, let's say, a fraud proof finds that there is an incorrect transaction, then the entire rollup can roll back. So this process of submitting the transactions, waiting for a certain period of time where somebody can, submit a fraud proof and the block can roll back, it takes a certain period of time. Right now on Optimism, it is 7 days. There are some initiatives happening to reduce this time from 7 days to lesser than that. But yeah, so that is one big limitation, I would say, of optimistic rollup as of now. So what are the benefits of optimistic rollup? So one, of course, you have lower gas fee because again, it's your own rollup. You control the gas fee. You are moving the competition. You are having your dedicated resources. You have a higher throughput, faster confirmation time because you pretty much have instant confirmation happening on L2 chain. Right? You're not limited by the latency which is happening on the main chain. And it is compatible with existing smart contracts and tools. So today, optimistic rollups, they support all the tools that you typically use for any EVM chain, whether it be Solidity contracts or ERC20 tokens, MetaMask, Remix, Truffle, etc. And then, you derive the security and decentralization from the base chain and fraud proofs. So that way you are getting the security and decentralization from the main chain, yet at the same time, you're running your own application-specific blockchain. What are the challenges? One is fraud-proof delay. So this process of 7 days, which is there in Optimism, that means what actually it means. So your transactions are finalized on the rollup, and still there is a time where fraud-proof can be submitted and your transactions can be rolled back. So that means that transactions have been confirmed but not been finalized. So in the case of optimistic rollups, till the time this period of 7 days, the finality does not happen. So this definitely impacts user experience, especially let's say you want to withdraw your tokens from the main chain. Then that would not be possible. Your tokens are locked for a period of 7 days till the time that block is finalized. Second limitation is that, as I mentioned, there's an off-chain data. All the transaction data resides in an off-chain database, a decentralized storage or any kind of storage. And that storage itself, may become inaccessible. Maybe it may get corrupted, etc. And as I said, this off-chain database is very important because you are creating your fraud proofs using this data. So if this data is not available, of course, you won't be able to submit fraud proofs. So that is a challenge. But now a lot of initiatives are there where we are decentralizing the off-chain data to make it more secure, and there should not be any data availability kind of challenges. There's a sequencer centralization risk. So both in optimistic rollups and ZK rollups, there's a sequencer which sequence the transactions. So transactions, it's very similar to how we see on standard blockchains also. So your transactions are there right now. Validators actually sequence the transaction. They can choose, your miners and validators, they can actually choose which transaction to include in a block or not, right? And so in this case also, you have sequences which sequence the transactions and then aggregate them into a block. So there's a sequencer centralization risk. Most of the early optimistic and ZK rollups have centralized sequencer, but now there are few players like Radius, Espresso, who are launching decentralized sequencer, and then in fact protocols themselves are getting into decentralizing the sequencer piece. And then there's a compatibility trade-off, like for example, optimistic rollups inherent Ethereum limitations as part of the Ethereum compatibility. So there may be, let's say if you're running a complex smart contract, then there may be a limit on the gas fee that can be spent. So you may be limited by the limits which are there, which is not the case, not the case in the case of ZK rollups. Now we come to ZK rollups, leading players being ZK Sync and Polygon CDK. So one, before getting into ZK rollup, so this ZK EVM chains that you must have seen, ZK Sync has launched ZK Sync Era, which is a layer 2 ZK based chain on Ethereum. Similarly, Polygon ZK EVM was launched in March, and again a ZK based chain on the Ethereum network as a layer 2. What we are talking about today is a bit different. Like in the case of optimistic rollups, there is an Optimism, which is a layer 2 on Ethereum. There is Arbitrum Orbit, which is again is a layer 2 on Ethereum. Both are based on optimistic rollups. but they are independent public chains, layer 2 chains on top of Ethereum. But at the same time, what Optimism and Arbitrum did, they open sourced and opened their underlying technology stack. So it is called OP stack, which is optimistic rollup stack. And you can actually use this stack to launch your own rollup. So that is what we are trying to cover today, because the whole topic is how to create your own application specific blockchains, right? So there, using OP stack, you can create your optimistic rollup. Similarly, in the case of ZK rollups, Polygon has launched Polygon CDK, which is the chain development kit, which allows you to launch your own layer 2 ZK rollups on top of Ethereum. Similarly, ZK Sync is also coming up with their own technology stack to launch your ZK rollups on top of Ethereum or ZK Sync Era chain. So from a business standpoint, optimistic rollups, ZK rollups, both are rollups, and you can use either of them to launch your own rollup. In terms of maturity, optimistic rollups came in first. They are quite mature. A lot of startups and enterprise startups mainly are using optimistic rollups to launch their rollups. ZK rollups is right now, it's in the process. So 2023 actually saw the launch of testnets by Polygon, and then ZK Sync also has been running their testnets for almost a year. They're coming up with their mainnet by the end of this year. So ZK rollup is still in the stage of maturation. So they are still maturing, but yeah, we are going to see, we'll start see production level ZK rollups happening starting next year in Q1. So why they are called ZK rollups? Because ZK rollups used zero knowledge proof. So here you're not having validators who are validating, and then you are submitting the block of transactions on the main chain, and then there is a fraud proof. There's no concept of that. Instead of that, there is a prover node which is running zero knowledge based cryptographic algorithms, and they generate ZK proofs, and these ZK proofs are then submitted on the main chain. So in this case, in the case of ZK rollups, you're not submitting the transactions on the main chain, but the zero knowledge proofs of those transactions on the main chain. So of course, a prover is very compute intensive because you are generating these ZK proofs. But the best is that, once the prover generates a proof for a batch of transactions, it can be verified very easily, very quickly. So you can easily see, by just running a proof, that these proofs match, and you can be sure that no meddling of data, no tampering of data has happened. Right. Now, I'll first come to this. So benefits and challenges on the ZK rollups. So one, again, lower gas fee and high throughput is pretty much same as optimistic rollups. One thing which is different is faster confirmation and finality, because in the case of ZK rollups, there's no concept of fraud proofs. There's no need to wait for 5 days or 7 days. So there's an instant confirmation, instant finality on the layer 2 chain that happens, and it improves the transaction latency. Privacy features. So you can use transaction privacy by using ZK proofs, because no transaction actually gets submitted on the main chain. So if you're, let's say, running a private chain, and so ZK rollup is an excellent choice. A lot of enterprises are, in fact, looking at ZK rollups. A lot of DeFi startups, payment startups are looking at ZK rollups. And then security and decentralization, again, they derive the security and decentralization from the base layer of the main chain. The challenges is proof generation cost. So right now, the prover node is a very expensive. It's compute hungry and takes a lot of resources. But the good thing is that a lot of initiatives are happening where this is getting better and better. So as technology mature, we are going to see generating zero knowledge proofs will become very cost effective. Right now, they are a bit expensive. And then there's a concept of circuit complexity, which is based on the how the design happens or the transaction type happens, and that may impact the scalability of your ZK rollup. And then there are compatibility issues. So ZK rollup has got like initially when ZK rollup came, they were hardly compatible with your EVM contracts. What I mean by that is that if you are running some smart contracts on Ethereum main chain, you could not migrate them easily. You had to make some changes. But now, as you know, we are moving up the maturity in the ZK Rollup space. Now, the Ethereum compatibility is not limited anymore. It is very extensive, and it would be very easy to migrate your decentralized applications or smart contracts on a rollup. So this is different components of a rollup. So you launch a rollup, which is a layer 2 in itself, and you launch a decentralized app on that, your set of smart contracts. Then there are users who are doing a transaction on your layer 2 rollup. The transactions are sequenced using a sequencer node, which sequence all the transactions, batch them together in a specific order. And then, there's a prover node which runs the cryptographic tools like zk-SNARK or zk-STARK to generate the zero knowledge proofs. And then these zero knowledge proofs are verified on the smart contract on layer 1. And then, once they are verified and submitted, then the state is updated on the layer 2 as well. So in this case, the process is very straightforward. There's no concept of fraud proofs, and these zero knowledge proofs can be easily verified. So this is a brief about Polygon CDK. Polygon CDK was launched some time back. It's part of the Polygon 2.0 initiative. And using Polygon CDK, you can actually launch your custom ZK rollups very quickly. It provides you all the necessary features, starting with your necessary rollup infrastructure to sequencer, prover, and then various other components. Some of the so right now we do not have any CDK-based ZK rollup in production, but yeah, there are quite a few customers who are moving their existing infrastructure, maybe running on main chain or maybe running on optimistic rollup or some other infrastructure. They are moving to ZK rollups. Canto, Wirex, Manta Network. There are quite a few Gnosis Pay, Astra Network, etc., which are moving to ZK rollups. So yeah, so this is pretty much I wanted to cover. So you got a flavor of launching your app chain using Cosmos the substrate, or using Avalon subnets, Polygon supernets, or using optimistic rollup or ZK rollups. One note at the end: Zeev is the leading rollup as a service provider globally, and we support both optimistic rollups as well as ZK rollups. For Polygon CDK, we are the key implementation partner for Polygon CDK, and we support launching your ZK rollup in a very automated and standardized manner, so that you get the best of infrastructure without worrying about the complexities of the underlying rollup infrastructure. Yep. So now I'll open the anyone has any questions, I can answer.
Quite interesting and insightful, Ravi. A fascinating presentation. Thank you so much for your unwavering support in imparting this knowledge to our community. So we'll be opening the floor to questions from the chat. As I see, we don't have any questions on the chat at the moment, but I had a few questions myself which I wanted to get cleared, and were running in the back of my mind. So essentially, one of these questions was that how do these technologies contribute to scalability and performance improvement for blockchain applications?
Right. So basically, what you are doing is using an application-specific blockchain means you are launching your own blockchain, and you are from a main chain perspective. Let's say from an Ethereum perspective, you are now doing all the transactions off-chain rather than doing it on-chain on Ethereum. So that way, you are reducing the congestion on the Ethereum chain, right? So you improve the scalability of the Ethereum ecosystem. And on your rollup side or on Appchain side, you have your own dedicated resources. You do not need to worry about the gas fee. You control everything. And if you want to implement some additional features like privacy compliances, etc., you can do that. So that's how by getting the transactions off chain, you are bringing scalability on the main chain.
Got it. And what are the challenges and optimizations that are involved in ensuring compatibility with existing smart contract standards?
Yeah. So as I mentioned, like there are various ecosystems. So if
Mhm.
we talk about, let's say, Ethereum ecosystem. So in
Yeah.
the Ethereum ecosystem, we talked about the options like Avalon subnets or Polygon supernets. So both are EVM compatible app chains, and all your tools of the Ethereum works as it is on either of Avalon subnets or Polygon supernets. Similarly, if you talk about rollups, so both optimistic rollups as well as ZK rollups, they support EVM compatibility. So again, all your tools work as it is. All your smart contracts application will work as it is on optimistic rollups and ZK rollups. Now, if we talk
Mhm.
about Polkadot substrate ecosystem, then any chain which is built using substrate, of course, has got compatibility with all the tools which are there in the Polkadot ecosystem.
Yeah.
And same goes for Cosmos ecosystem. So there are three prominent ecosystem as we see today:
Mhm.
Cosmos, Substrate, and EVM, Ethereum ecosystem.
Yeah. And how can these potential challenges be mitigated, and what lessons can be drawn from past experiences of these challenges?
Yeah. So see, like technology takes time to mature. So today, if for we are seeing ZK rollups, which is technology wise, it's highly innovative. It's pretty cool to launch your own rollup. But yes, it is taking a bit of time to mature, and we are pretty much there. So 2023, a lot of innovations and happened in the ZK rollup space, and we are now starting. Customers have started, getting into test nets or dev nets, started building on top of it, right? So challenges are always going to be there. One thing at Z, what we have understood is that app chains is the future. Like,
Mhm.
we saw people launching their own application specific blockchains because you require more control. What
Yeah.
happens is, if you're launching a new dApp, you can deploy easily your smart contracts on the main chain and don't need to worry about the underlying infrastructure at all, right?
Correct.
But the thing is that congestion problems, predictability problem, etc., are happening, and that's why as you grow, you find a need to move to your own app chain infrastructure. So either a lot of startups and enterprises are choosing app chain as the first choice, or they are first deploying on main chain, and as they grow up to a certain extent, then they plan to get into. So, for example, payment startups. If you have startup, you already have got millions of users, millions of transactions happen every month. It makes sense for you to go for your own app chain infrastructure
Yeah.
to reduce the gas fee, increase transaction throughput for your users. You will give better UX, UI, better usability, user experience to your users, right? So,
Mhm.
that is how it is going to happen. So, at Z, what we are doing is, you launch your app chain, and still we make the infrastructure so simple, so straightforward for you that you don't need to worry about the underlying infrastructure. For you, it's we set up a proper enterprise grade app chain infrastructure and manage it on an ongoing basis. So from a startup perspective and enterprise perspective, you can simply come, deploy your contracts, and keep going. You don't need to worry about the underlying infrastructure.
Got it. Perfect. So that's absolutely well answered, Ravi. I think that cleared most of my doubts for you. I don't think so. We have any other questions from the community. I've also attached your LinkedIn handle in case people want to connect with you. They can feel free to do so as well. And to conclude, I
Absolutely.
think, yeah, I think the journey from ideation to implementation in launching a rollup and Appchain encapsulates the dynamic evolution of blockchain technology. And as these solutions unfold to address scalability challenges and enhance decentralized applications, the collaboration of developers, the engagement of vibrant communities, and commitment to continuous improvement become the keystone of success. And navigating the intricacies of scaling solutions reveals not only the technology prowess, but also the collective efforts required to usher in a new area era of efficiency, interoperability, and widespread blockchain adoption. So, with this, we come to an end of this masterclass. I would like to express my gratitude to Dr. Ravi for taking out his valuable time to educate our community. We look forward to hosting you in our future online sessions, as your expertise in such topics lie at a higher level than many other leaders in this ecosystem. Do feel free to connect with Dr. Ravi via LinkedIn as provided on the chat for any kind of questions you may have regarding this session. Thank you and have a good evening to everybody else who joined today.
Thanks. Thanks, everyone.